All right, here is the 7.5 chapter review solutions. Again, if you look to the right of your screen, you can see the problems that I'm grabbing from to work one at a time. Okay, so for number 52, we're talking about exponential and logarithmic equations, right? Easier to work than it is to say, so don't worry. All right, we're going to solve each equation. We're going to round to the nearest 10,000th. Now, the ones I can solve by hand, I'm going to solve by hand. There's a little example for you here. But here's what I have. I have 25 raised to the power of 2x equals 125. I really would love to just do this. I'll show you how to do it in the calculator afterwards. All right. So, but first, I'm going to show you one way you can do it by hand. 25, we could write it as a similar base. If you happen to recognize that 25 and 5 have a similar base, that base is 3. So this is 5 to the third, this is 5 to the second, this is 5 to the third. Well, that's just what 25 is. 25 is 5 to the second. But there's also this 2x here, right? So there's another 2x. So here's what this is. If you take the 2 and multiply the 2, you get 4. So this is 5 to the 4x is equal to 5 to the third. So we changed the base to solve these. Well, if they're both base 5 and they're both come up to the same thing, that means these exponents have to be equivalent, right? So here's what that means. That means that 4x has to equal to 3. And so that means if you divide by 4 on each side, x equals 4/3. Boom. Now, here's what really I did to drop that out. Okay? I have to log base 5 both equations, and it's like the log base 5 and the 5 cancels out, and it drops out the 4x equals 3. But it's just sort of a common sense thing. If 5 to something equals 5 to something, you know, 5 to potato equals 5 to banana, then potato has to be equal to banana, right? That's how I know those exponents are the same. All right, when I get to the ones that you have to do by calculator, I'll do those, but it just goes to show you that you can do these. Some of them you can do by hand. And they say round to the nearest 10,000th. This one is just, it's 4.3 repeating. It's an exact answer. I can leave it like that. You could do 1.3, sorry, 4/3 is 1.3 repeating, yeah. You could do it like that. Or since they say you can round, 1.333 is actually okay. Since they say you can round to the nearest 10,000th, I better put an extra 3. There we go. All right, next one, number 53. Okay, I'm solving equations that involve logarithms, or I'm using logarithms to solve exponential equations. I got 3 to the x equals 36. Now, you can't just divide by 3. You can't do any of that. You have to get this x out somehow, okay? So here's what we do. How do we get x's out of the exponents? We log both sides. Now I'm going to use log. It doesn't matter if I use log or ln. I showed you in class both work. But here's what we get. Log of 3 to the x is equal to log of 36. Now here's why we log that side. It drops the x down here, so we get x times log of 3 equals log of 36. Well, how do you get the x by itself? It's being multiplied by log of 3, so divide by log of 3. So we get x, and then these cancel out on this side right here. So what we get is, we get x is log of 36 over log of 3. Now, I don't know what either of those are. I don't know what log base 10 of 36 is or log base 10 of 3. So I'm going to use my calculator to answer those. So I like it, it's a little prettier when you do alpha y equals. So stack them up into a fraction here. We'll get it one day. There we go. So, and I'm going to do log of 36 over log of 3. Now, it might make you OCD that I didn't put the parentheses, but I can just get away with doing that. Notice how my calculator automatically puts the parentheses. So I'm just saving time by not typing it. But let me show you something else. Let me show you that when I said it didn't matter which log button we use, I'm going to use the ln button. ln of 36 over, ln really stands for natural log, ln of 3. Boom, you get the same answer. Okay, if you don't have to know why. Okay, it's just cool that it works. Isn't that great? That hey, it doesn't matter what log you use. So the good news is whenever you're solving these, if you want, always use the LOG button and never use the LN button, or always use the LN button and never use the LOG button. In these kind of problems, I don't want to say it's like they cancel out, but it just works out, right? No matter what base of log you use. This is log base 10. This is log base E. These are not the same thing. I'll prove that to you. Now this is what's weird. Let me show you this. Log of 36. Notice how you get that number, but if I do ln of 36, I'm going to get a completely same or different answer. Let's see. Whoa, what? How are these the same? Well, it's just like, well, the natural log and log of 3 are different, so it just works out. All right, I'm going to fly through the rest of these because now we got the properties. The properties are to get rid of exponents down, you log both sides. We're just going to apply that, and we're going to move through this a little faster. 54, we have 7 to the power of x minus 3 is equal to 25. They don't have a common base. You cannot do this by hand. Okay? There's no like, oh, what's the common base for 7 and 25? They have nothing in common. So I'm going to log both sides. And here's the thing. This exponent I'm going to put in parentheses just because it kind of helps me. So I'm going to do, I have log base 7 of x minus 3 is equal to log of 25. And here's the thing. This exponent can kind of be brought down in front. So I have x minus 3 times log of 7 equals log of 25. Now remember, the point is to get x by itself, right? So here's how I get x by itself. Don't add 3 right away. You're eventually going to add 3, but it's like, look, you got to get rid of the multiplication part first. Let me divide by log of 7 on both sides. And so I get x minus 3 equals log 25 over log of 7. Now, how do I solve for this thing? I add 3 on both sides. Notice how I didn't consult my calculator yet. I have not yet touched my calculator. Please, when you're solving these, don't use your calculator to the very end. X is equal to log of 25 over log of 7, and then you add 3. You can check your answer too if you want to, and I will do that just this one time. But don't use your calculator to the very end. I'm going to type in this stuff now. Log of 25 over log of 7. Okay, and this time, you know what? I'm gonna put my parentheses off at the end, just cause, the calculator will add them for me no matter what. All right, but then I'm gonna add the 3. Notice how I don't even hit enter right here. I don't hit enter then add 3. I just put it all in at once. Boom. Now how can I check if this is the right answer? Okay, here's what I can do. I can take this answer and store it, all right, but I can just grab it too. I'm going to take 7. If I raise 7 to the power of whatever this number is, minus 3, it should give me whatever log of 25 is. So let me show you that you can check your answers and equations, just like we did in algebra. So I'm going to do 7 of, if you do second answer, it grabs that. You can just type 4.654 if you want, but I'm just grabbing the answer exactly. Minus 3. Now here's what I get. I get 25. So if you look at your original equation, 7 to the power of whatever that weird number is minus 3 gives you 25. Since it came out with 25, I know I did the problem right. All right, next one, 55. All right, let's do, all right, this one we have log equations. And then we're going to use exponents to solve for them. So this is log of 3x equals 1. Now here's the thing. This is an invisible 10 right here. This 10 is understood. So here's what you do. You take both sides and you make them the power of 10. So you get 10 to the log base 10 of 3x equals 10 to the first. All right, what happens with these, they cancel out. You can confirm that in your calculator, but you get 3x equals, now this one 10 to the first power is just 10. How do I solve for x? I divide by 3 on both sides, so I get x equals 10 thirds. Now, you can put this as a decimal if you want. This is going to be 3.3 repeating, you know, as a decimal, but 10/3 is fine. All right, so if you want to solve for things with exponents, you if you want to solve for things with exponents, you use logs. If you want things to solve with things with logs, you use exponents. I actually made a mistake here. I actually did 56 before I did 55. So let me back up and do 55. Let me do it right here since I have room. This is 5 to the x plus 3 equals 12. All right, now you might think, oh, I got to log both sides. Let me log base 5 both sides. Well, slow your roll. Here's the thing. Before you log, you want to get it to where there's just the part with the exponent kind of hanging out by itself. So here's what you should do first. Subtract 3, okay? And now I get 5 to the x is equal to 9. Now I want to use some logs. And again, it doesn't matter what kind of log you use. I'm going to log both sides. Okay? And so I get log of 5 to the x equals log of 9. And so what happens is the power property of logs lets me bring this x in front. X times log of 5 is equal to log of 9, and then I divide both sides. Log of 5 divided by log of 5. So x is equal to log of 9 over log of 5. So I'm just going to type that into my calculator. I'm going to type log of 9 over log of 5. Oop, my mouse is really dancing around today because it's I'm actually moving it on something that is not a piece of paper. Alright, so I'm going to type log, I'm going to do this one without doing alpha y equals. Log of 9 over log of 5, and there's your answer. I'm going to round that to the nearest thousandth, so this one is 1.3652. They say nearest 10,000, so 4 decimal places is what that is. I noticed I didn't put my earlier one, which is the one right here. This one came out to 4.6542. So I'm going to write that down. 4.6542, because you got to round up 1 decimal place. That's it. All right, I'm going to go ahead and stop the video here, and I'll work the next few just so the videos aren't too long. I'm going to work the next few on a second part. So starting with 57, I'll work the rest of them.